Robotics 20 students, good morning, good afternoon, good evening, good middle of the night, whenever it is you're watching this video. Welcome. Today we're going to carry on with exploring some sensors for the Sensors 1 research assignment. And we're looking at sensing rotation in a very basic way. We'll look at a more advanced way later on, but we're going to be using potentiometers to sense rotation. This is probably going to be a review of stuff you covered last year. It's always good to go over things and rebuild kind of that foundation. So we're going to be doing some breadboarding, we're going to be doing some coding, and we're going to just look at some results and talk about next steps. So let's hop into Tinkercad and take a look at where we're at. So this is where we left off last time. We've got our touch sensor, aka just a simple push button here in our breadboard. We're going to go ahead and get rid of that. We don't need it right now. We don't need this resistor. We'll deal with a signal connection later. Let's just clear our breadboard, get us back to square one, and we will bring in here a potentiometer. So you've seen these before. The ones you have in your kits, if you still have those, probably look a little different than this image. They probably look like a metal kind of knob in some PCB with, again here, though, 3 pins sticking out the bottom. Probably has something written on the top like B10K or B100K telling you something about the total resistance, but it doesn't really matter for the purpose of this exercise specifically what resistance you have. Really quickly, let's talk about the anatomy of a potentiometer. So we have 3 pins here and some kind of a knob, a dial. What's going on inside of this, if we could crack this open, is we would see between this pin and this pin, the 2 outside pins, between those 2 all the way around is a big long resistor. And whatever's written on the top of the potentiometer is the resistance of that big long resistor. So the ones that I have in my kit here are 10K, so they're 10,000 ohms. So we've got a 10,000 ohm resistor between these 2 pins. So no matter what we do, there's always 10,000 ohms of resistance between this pin and this pin. That doesn't change. What does change though is this pin in relation to those 2. So what this pin is connected to inside is it goes in and then it's connected to this piece of metal that we call the sweeper. And that sweeper, as we move this dial, moves around and contacts that big long resistor at different points. So when it's all the way over here, it's basically not touching any part of that resistor. It's right on the edge. So between this pin and this pin, we just have a short circuit actually. No resistance, okay? Because the current can come up through this pin, and before it even gets to the big long resistor, it can go up through the sweeper and back down through this pin. No resistance. At the same time, between this middle pin and this pin, right now in this position, we've got the full resistance of the potentiometer. So in my case, 10,000 ohms. So from here, a current would have to go up through this pin, down through the sweeper, and then all the way through that big long resistor, all the way out the other side. Okay. On the other hand, if we were to turn this knob all the way in the other direction, we would get the same kind of phenomenon, but opposite. So between this pin and this pin, there'd be no resistance. And between this pin and the middle one, we would have to go all the way through the big long resistor. So that's kind of interesting, but where things get really useful, of course, is the fact that we could put this knob anywhere in between, and that will change the resistance between these 2 pins and also between these 2 pins. Which pin you want to be on or off or high or low doesn't really matter. That just depends like which way you want to have to turn the knob to like turn the signal up. Electrically, it makes no difference. There's no like positive or negative here. So let's look at how we connect this into the breadboard. Zoom out. Very important that we plug it into the breadboard in this orientation so that each pin ends up in its own row. If we rotate this around and put it in like this, we now have all 3 pins connected to the same row, so they're all just connected together. So there's no reason for any current to want to go up and through this potentiometer at all. It might as well just go through the breadboard. So we don't have anything going on here. This isn't useful. So we want it like this, each pin in its own row. Okay, and I'll put it just up here so that we have lots of room to connect down here. In real life, you might put it down here and be plugging in behind it, but we don't have like 3D space in this simulator. So how do we hook this up? very simply, if we just want to like get a signal into the Arduino of what is the rotation, we can connect positive up to one of these outside legs. Let me turn that to red. We can connect our negative to the other outside leg. We'll go with blue. And then this middle leg, we're going to connect to the Arduino to do the sensing. Now, in the last video when we were looking at digital input, sensing a digital sensor, like the push button, we were using the digital pins, which are these ones numbered 0 through 13 on the Arduino. What we're sensing right now is analog in nature. Analog meaning it can take any value between off and on. There is such thing as an in-between, and it's a continuous curve all the way up from 0 to 1. Digital, remember, meaning can only be off or on, 2 values only. Analog, any value in between. So we can't measure that with these digital pins on the Arduino. So we're going to go and use these analog pins on the Arduino instead. So I'm going to hook this up from this middle pin, and I'll just choose A0 on this. That's all the circuitry we have to do. Very simple, very straightforward, just to sense the rotation of this potentiometer. Now, what would you use a potentiometer for out in practice? Very simply, just any kind of knobs or dials on something that like a human would control. But you could also imagine hooking the potentiometer up to like an axle of some part of a robot, and then you would be able to know where in the rotation of that axle it is. Now, normal potentiometers can only go around a limited number of times, usually just about 180 degrees or maybe 270 degrees, or sometimes, around 360. You can get potentiometers that can go 10 turns around, but eventually you'll get to a limit and you'll have to go the other way. And if you try and drive it past that limit, you'll probably damage the potentiometer. So you wouldn't want to hook this up, like attach this to an axle of a robot's like drive wheels that's going to continually rotate as many times as needed, because eventually you'll hit the end of that potentiometer. We'll see another way of measuring rotation later that can do this. But most of the time, if you're using a potentiometer, it's for some human interface, and the human is turning the knob, like the volume knob on an old like radio set or something. One other thing we'll just mention, this circuit is so simple that it's a little bit overkill what I've done here with so many connections. Realistically, I could get rid of this. I could move this jumper to here. I could get rid of this, and I could move this jumper to here. And electrically, that's the same. I just like having it set up like this because if I were to want to add anything to this circuit, it's nice having my power and ground separated out. And I don't want to have to like do that after the fact, or like be connecting other things into here that need power and ground. It just gets a little awkward. You do you, okay? For something this simple, don't do this much overkill. Right? I've added 2 extra jumpers that I don't really need. So that's the circuitry. Very simple, very straightforward for rotation sensing with a potentiometer. Let's take a look at the code. It's also very simple. We'll learn a neat trick with the Arduino serial monitor, and then we'll talk a little bit about what you can do with this knowledge. So we'll hop into our Arduino code editor. This is just the code we had from last time from the push button. We'll get rid of a lot of this and kind of start from scratch. You can start a new file if you want to save this as something else. I'm going to get rid of this pin mode stuff. I'm going to get rid of all of this stuff in the loop, and we'll start from scratch. I'll do the same thing as I did last time, where I will skeleton out, stub out my plan with comments and then fill in the blanks. This is a good practice to get into. It's a good habit. Not only does it help you think through the process before you try to figure out how to translate that into Arduino language, but also is helpful later when you come back to a file and you can see those comments there and you know what parts of code are doing. So we still want the serial monitor up. That's great. We actually don't need to do anything else in setup for this one. All we want to do here in loop is we want to read the value of the analog input, store it, and print the value to serial. Okay, same algorithm as before, very straightforward. Get a value, store it in a variable, print the value to the serial monitor. How we do that looks a little bit different for analog versus digital, but it's very, very similar. So step one, we want to read the value of the analog input and store it in a variable. If we want to store it in a variable, we should probably set up that variable first. So we'll make a new integer variable. We'll call it analog value, analog val maybe. And then I'll split this up into 2 steps. We'll condense it down into 1 line of code in a second. But now what we want to do is we want to set that to the return of analog read, and we can say A0. Now you notice I didn't do pin mode again. I got rid of that. That is because the analog pins on the Arduino are only for inputs. So we don't need to tell the Arduino that we're using it as an input because there's nothing else you can do with it anyways. And here we're using A0 as the pin for analog read to signify it's the analog pin that we're trying to read the value of, not like digital pin 0. You notice as well that I'm using analog read, and when I typed it, it turned orange because it is a special word or a special term, a function in the Arduino language that means something. And so when it turns orange, you know you're on the right track if you're trying to do something Arduino specific like this. What analog read does, exact same thing as digital read, is it just checks the value of the voltage on this pin, returns that as a number, and we'll see what kind of number in a second. And then we're just saying, okay, whatever the result of that is, store it in our variable analog val. Just to make things simpler, I'll condense that into 1 line. So we're both creating the variable and setting its value in one go. Lastly, we want to print the value to the serial monitor. So we can just say, once again, serial.println analog val. So this is all the code we need to be very quickly sensing the rotation of the potentiometer. Let's upload this to the Arduino and see what kind of numbers we get. So very first thing I always want to do is go under Tools and go under Port and check that I've selected the correct port. Okay, likely the one that your Arduino is plugged into will have in brackets Arduino. Sometimes it doesn't. If you don't know which COM port it is that you need to use, just unplug your Arduino, close this menu out, open it again, and you'll see 1 less number there. Plug your Arduino back in, close this menu, open it up again. Whatever number just appeared, that's your Arduino. Now we can go ahead and upload this. I do have an Arduino plugged in today, so we're gonna upload this. And now that it's done uploading, we'll see, once again, nothing's happening. That's because we need to go to our serial monitor to see anything happening. You can get to that by going to Tools, Serial Monitor, or Control-Shift-M, or just this little magnifying glass in the top right. And what we see is a string of numbers going through. Currently at 1023, I've got my potentiometer turned all the way in one direction. As I start turning that in the other direction, we'll see those numbers start to go down. I'm turning my potentiometer all the way down. Now it's all the way the other direction, and we get all the way back down to 0. And we can see if I turn it like halfway, we'll get somewhere in the realm of like 512. That's about halfway on my potentiometer, and any value in between. You see there's a little bit of jitter. Right now I'm not touching the potentiometer, and it's kind of flickering sometimes to 812 and then back to 813 or maybe 814. That's just because with electronics, there's always a little bit of fluctuation, right? And we turn that all the way up, and we see the maximum value once again is 1023. And that's kind of curious. Why 1023? We have right now hooked our Arduino up between 0 and 5 volts is what we're getting on that line. But the Arduino is interpreting that as something between 0 and 1023. The reason this is the Arduino is taking that value between 0 and 5 volts, and it's just converting it into a number between 0 and the biggest possible number it can represent. So it doesn't know that 5 volts is a special number 5. All it knows is 5 volts is maximum voltage. So it's converting that signal into a number between 0 and maximum number, whatever the maximum number it can represent is. Why 1023? Why is that the biggest number that it can represent? That comes down to the fact that computers count and manage and add and multiply and deal with numbers using binary number system. Why is this important? Well, the binary number system represents values, place values, as either zeros or ones. Our number system, the base 10 system that we use, any place value can take the value between 0 and 9. And if we're counting, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when we run out of digits, we want to add one more, we return that place value back to 0, and we add 1 to the next place value. So now we have a 1 and a 0. And then add 1, so we get 1 and a 1, add another 1 and a 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. And now we've run out of digits, so we return that one back to 0. We add 1 onto the next one. So now we have 2, 0, and so on and so forth. Okay. Binary number system works exactly the same way, just instead of having 10 digits to work with or 10 numerals to work with, from 0 to 9, we only have 2 numerals to work with, a 0 and a 1. So what this means is, with a single digit, we can represent 2 numbers, 0 and 1. With 2 digits, we can represent 4 numbers. Okay, we can have 0, 0, 0, 1, 1, 0, 1, 1. We have 4 numbers we can represent with 2 digits. With 3 digits, we could represent 8 numbers. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. That was 8 numbers. Okay, so we went from 2 being able to represent 2 numbers to 4 numbers to 8 numbers. And you might predict that as we add on more digits, we just double the total number of numbers that we can represent. 16, 32, 64, 112, 256, 512. I've messed up somewhere along the way. We end up with, if we have a 10-bit number, 10 digits, the biggest number we can represent is 1023. We actually have 1024 numbers that we can represent, but because 0 is one of those numbers, the biggest number we can actually show is 1023. So that's why that's kind of a special number. It's a bit of an aside. It's not really important for you to know. The important thing here is just that we've got access to our signal from our potentiometer. We know it's something between 0 and 1023. Let's see a few kind of neat things we can do with this to make this maybe a little bit more clear or a little easier to work with, depending on what you're trying to do with this potentiometer. One thing I want to show you that's pretty cool built into the Arduino IDE is under Tools, not only do we have a serial monitor, we also have a serial plotter, Control-Shift-L. If I open that up, as long as the values that we're sending to the computer over serial are just numbers and not text or anything else fancy, if it's just a number that we're sending over and over again, we can use the serial plotter to view the graph. And so right now I'm going to turn my potentiometer and we can see the graph. Now it's just adjusting its scale now that I've kind of changed what it should be expecting as its maximum. And what we can see is as I'm wiggling this potentiometer back and forth, we're seeing those values. So that can be kind of handy depending on what you're doing, especially when we start looking at like sound with a sound sensor, a microphone. Being able to plot that and view the waveform is going to be a lot more interesting than looking at a string of numbers fly by. So that's pretty cool. What else can we do with this? Well, sometimes we actually want to know what voltage that line is at. We don't care about this like 0 to 1023 business. I actually want the number between 0 and 5. Let's do that really quickly here in the IDE. Before we do that, I'm just going to tidy up our serial print a little bit just because we're going to be printing multiple numbers and I want things to remain clear. So before this analog value, I'm also going to add a serial.print and then just some text. And we'll just call this raw value, space, and end quote. So if I want to just send raw text, once again, it has to go inside quotation marks. And then anything in here isn't counted as code. It's just the English text that I've typed. So I'll upload that just so you can see what this is doing. And in the serial monitor, we can see now I'm getting that text and then the value from the potentiometer. And as I move the potentiometer, that value still updates. So that just makes things a little bit more clear. That's kind of nice. Now, what I want, once again, is to take this number that right now is between 0 and 1023, and I want to store that as a value between 0 and 5 and print that out. So I'm going to make a new variable. I'll call this voltage. And what I'm going to set this equal to is the result of this function that, again, is built into the Arduino library, and it's called map. Map is a very, very handy tool to use. I'm going to type it all out and then explain what it does. So map takes in 5 arguments, all separated by commas. The first one is going to be analog value, analog val, this is a variable, 0, 10, 23, 0, 5. I've added these spaces here just to keep things a little neater and easier to read. You don't need them. They don't really count in the code. It just helps us take a look at it a little bit easier. What map does is it takes any value that is within a certain range and converts it or scales it to be within a different range. So what I'm saying here is take this analog value, whatever number is stored in here. Right now it's somewhere between 0 and 1023. I would like that as a value between 0 and 5. So that's what map does. It returns the result of that. And right now I'm just storing it in this voltage variable. So I want to also print that. I'm going to copy this here. We'll call this voltage. And we'll print the actual variable. I'm just going to remove this println here. The difference between print and println is that println hits enter at the end of it, like it starts a new line. Prints just would carry on the same line. So I have all of these as prints, so they print on the same line. And then the very last one is a println, so that the next time through the loop, we're going to print this data out on a new line. I'm also just going to add here some spaces before this voltage, just to separate it away from the value from analog val. So what we're seeing is the integer value of the voltage. We're not getting the decimal. We're not getting, it's like not 3.5. We're not seeing that it's 2.2. We just see, is it 0, 1, 2, 3, or 5 volts? And it looks like it's rounding down. I have to get all the way up to 1023 for it to actually turn to 5 volts. Now, depending on your application, this might be useful. You might care about a fine-grained decimal point understanding of what the voltage is. To get that number involves a little bit more advanced programming than I want to go into for this lesson. So we'll leave that for another day. If you're curious, we can talk about it. You can hop in office hours and we can go over that together. But you don't really need it. If you do care about just having like a fine grain of changes of the potentiometer, just use this raw value. Okay, 0 to 1023 is plenty of granularity to do interesting things with. And you don't really need to have it between 0 and 5 because the stuff that we're working with doesn't have any understanding of voltage. And the fact that something is 5 volts doesn't really matter. Usually all we care about is where is it in between off and on. We won't go any further with this today, but we did cover some interesting stuff beyond just how to breadboard with a potentiometer and how to code with a potentiometer. We looked at some a little bit more advanced stuff with serial prints to keep things organized. And we also saw that really handy serial plotter, which will be useful to use for a few of the other examples that we'll go through. Still to come, we're going to look at some more advanced sensors. We'll look at the ultrasonic rangefinder, which is really the only active sensor on this list. We'll talk briefly about thermistors. We'll look at using a rotary encoder to measure rotation more accurately and to be able to do it continuously. And we'll look at microphones to measure sound and things that we need to do in addition to just having a microphone. We actually usually need to amplify that signal. So I'll go over how we do that with a little IC as well. So those will be future videos that will come out, maybe some more this week, probably into next week. One thing I did want to talk about though is now that you know how to use a push button and a potentiometer, there's actually a really great piece of hardware that comes in a lot of the Arduino kits. You probably have one, and it's these lovely little joysticks. And these are actually the exact same joysticks that are in an Xbox controller or any controller really. This joystick here is pretty much identical to this, just that this is out on its own PCB and this one's built into the PCB of this controller. But what's really interesting about these is inside of this, really all that we have is 2 potentiometers. Okay, one that's keeping track of this motion and one that's keeping track of this motion. And then of course there's like a spring in there as well to return it back to the middle. But if you look really close, and I don't know how well you'll be able to see in this video, and my camera's not going to focus, but right in there you can see that little that piece rotating a little bit side to side as I rotate this. And on the other side, there's another piece that rotates as I rotate it this way. And those are just very small potentiometers that work exactly the same way, are exactly the same hardware with 3 pins and the same resistor all the way through and a sweeper that sweeps along it. And so what we get out of this is just an analog signal in the exact same way. And that's how we keep track of X and Y motion on a joystick like this. And then a lot of joysticks on controllers have clicks to push. You can hear that. It's got a clicker. And all that is, you might be able to see it right there. Oh, will it focus? Right there is a little push button, almost identical to the ones you have in your kits, maybe a little smaller. And there's just a piece of plastic sticking out of the side that's attached to the joystick itself, that when you push the joystick down, it pushes down that push button. And so then we also have a digital signal out of this on one of these pins that's exactly the same as the digital signal that we saw from the push button in the last video. So with this knowledge, you could hook up one of these joysticks to 2 of the analog pins on your Arduino and the digital pin on your Arduino and see values streaming through on your serial monitor. But more interestingly, maybe down the road, control a motor or send signals to a game in a computer or a game made of LEDs on a breadboard, whatever. Lots of cool stuff. Very clever little design. And of course, this is now ubiquitous as the way to do joysticks. That's it for today. Much more to come. Again, let me know if you have any questions. Hop in the office hours. I'd love to chat with you guys, see how things are going, talk about your other classes. My alarm is going off. So that's time for me to sign off. Have a great week. Talk to you later. See you in a future video. And let my lovely alarm play us out.